There, now I'm in record.
Cool.
Okay. We're proceeding to wire lab number 6. And we've come across and we decided that we're going to color code our individual runs on the ladder. So first we're going to put orange wire on run 4. So we're going to use a orange wire going across run 4. So we're going to go master control relay to stop.
And this is a stop switch.
It is a stop switch this time. Excellent.
Hello?
Okay.
Stop
And,
to...
now we're going to go stop to just forward start.
Forward start to...
Forward start to reverse. And that would be reverse pin 3. So we're going to go forward start.
To reverse pin 3?
Well, pin 3 is reverse and on forward both. So there's 2 3s in your controller, and they go to the same place, and they already have a wire hooked on.
Right, we're wired up to 3.
Now we're going to hook a wire. The wires that run from the other side of the reverse contact to the forward relay and from the forward relay to the overload are already wired. So the next wire we're going to run is between the start and the stop, going to forward 2. I think that's a 2 on the forward.
And that is a black wire.
And that's going to be black.
One long enough to reach. side of start and 2, right?
Yes, front side of start and 2. Between stop and start and 2 on our reversing control. Okay, we're now running a black wire between 3 and our controller and our running light forward.
Oh, it's a stretch.
Now we'll be running a white-orange wire between the forward running light and between the forward relay and the overload. Thank you.
So that's already got 2 wires on it.
But you have another place it could be.
It could go down here.
Yes. If we need to run more than 2 wires to a particular terminal, then we need to put a terminal strip up to control those wires. on run 3, or run 6, and we're going to run a wire that is going to be yellow, and we're going to run that wire from between the start and stop, and we're going to run it to the reverse start switch.
Okay, never mind. We're certified.
Okay, now we're going to go from the reverse switch to the 5. On my controller.
Are you serious? Whoa. Back set of start reverse.
Did not change. That should stay the same. So you should never have to do what's above that line. You only do below what's below that line. So if you're adding wires or removing wires from up there, but before you start, you should have tested this to make sure it worked. So if it worked, then you just ignore it. And now you're going to run wires this way. Now, why do you have all these wires coming out when they're in the wrong spot? So these wires are not correct. They should be going to A1 and A2 up above somehow. Yeah, so you should have a wire that's master control relay. That's A1, that's A2. So you should have a wire coming from A1 from 3 to this guy. So where's 3? There's 3. And you don't. And we should have a wire from A2 going back to common, and you don't. So your master control relay system is not right. And you're going to have to make that right before you worry about what's underneath.
I'm going to go from front side of reverse start to 4. Contact number 4.
Now we're running a blue wire from between start and forward going to 4. And it's going to be a short wire because we're going to go from a wire that's already there. Because you have a wire going into 2.
Mm-hmm.
Well, that wire going into 2 is already coming from the other side. So if you go from 2 to 4 right now, you should be okay with a short wire.
But 2 already has 2 wires plugged into it.
Okay, well then you're going to have to go across then.
Ouch. Five's a reverse light.
Now we're going to go from 5 in the controller to the reverse light. And we're going to use a blue wire.
These tools are never where I want them.
Here. I can fit through there. You got plenty of room.
That's a 182. That's a common wire. You're doing a direct short there. Don't turn that on. That's a direct short. That's hot to common. When that turns on, you're gonna go from hot to common. What do my plans say? 5 to running light. Alright, I got 5 to running light. And now I need overload
You
too.
need to go overload to the running light. And what I would do is I wouldn't do that. I would go from running light to running light.
Yep.
And then you don't need a small wire to do that. So there seems to be something wrong. You're supposed to be coming from A2 back to common, and for some reason you're not doing that. Are you coming in here to hot, and you're not supposed to be hot into there, that's supposed to be coming from 3. Where's this guy coming from? This guy's coming from 6. No. So these guys
It's
are
not
all,
like I've changed it, this is 1 and 3 instead of
yeah,
one.
but this, A1, is not hooked up to there. And right now, you have him going right into hot, and he's not really supposed to be going into hot. What's supposed to be going into hot is this contact on the master control relay. So he's supposed to be coming in here under 13. So if I put a 13 here and a 14 there, that's the connection across him, 13 and 14. But right now, this guy isn't going to the right spot. He should probably be coming up to there as a common wire, up to A2. And then coming in A1 has to be 3 from him. So 3
I use
from him is right there. That's the,
I use 6. This is A2. This is A2.
A1.
I mean, this is A1, A2.
Right.
Okay, yeah, this is, so it's either goes to 10 or 6.
But it doesn't go to 6.
I just interchanged.
Yeah, but that's going to this control relay, not that control relay. This is the master control relay. That's this guy.
Okay,
This
so
is control relay. That's him.
this is this.
This.
This one is still this. Is that
That's right. Those are the 2 contacts
Okay, this is
coming
what
from
this
the
one.
master control relay.
Yeah, that's what gets confusing. This, I thought it was not.
This is an auxiliary contact from the master control relay. That's a contact from that.
Do you use that motor starter?
That's a contact.
In 6, no.
That's a contact from that.
This is another.
Well, not the way you have it written, but yes. So this is control relay 2. Control relay 2. And then this guy here is from control relay 2. And this guy over here is from control relay 2. And that together is from the time delay right there.
And this also from, what is this one from?
This guy is right over here, he's the master guy. Right there. Yeah, so they motor started. Maybe overloads down there, right? But you're not using 2 and 3 at all. So there's no wires in here at all. You're not using them.
Oh, no.
Who did that?
Okay, I think we have all the wires connected. So now we're wired up, we're ready to go, and our forward reversing controller should work.
This time.
And so we're going to turn on power. We're going to energize our control power relay. And now we're running forward.
And there's no forward light.
And there's no forward light on, so that's an issue. Okay, we're going to stop forward. We're going to run in reverse. So we have a reverse running light. Okay, we're going to go forward again. And now we're gonna push the reverse button. And nothing happens. Excellent. Okay, so now all we have to do is troubleshoot to find out why the reverse light is not coming, and the forward light is not coming on. First thing I would do is I'd look to see if my light bulb was working. That would be my first indication of what I would look at. So the light bulb looks good. But it doesn't come out. Okay, so we'll have to chase the wires back.
Or is it a component?
Well,
Unlikely, but it could be.
yeah, unlikely. Do you want to stick another light bulb in?
No, because that one works.
Oh, okay.
Gotcha.
Any light bulb in. Okay, it's supposed to be running between, onto one of the threes, is what it's supposed to be running, and it should be
It's hooked to 3 and it's got a good connection.
all right, and then it's coming back and it's hooked to the same common as the other guys hooked onto.
So do you want to try a different light?
No, I want to see. So, turn it on. And we're going to go forward, and we're going to see whether or not there's any voltage there. And what do I see?
112 volts.
Okay, so I have voltage there, the light should be on, so that means either the bulb's burned out.
But I put that bulb in it and that bulb's good.
And you put that bulb in it. So we switch out, so it has to be a fixture problem, so we'll go and remove the fixture. Put it in the
I have a bulb in it.
Yes. All right, now we're back to turning it back on. And we have a green running light. All right, hit the reverse button. Not much happens. Turn it off. Hit the forward button. Turn it off. Hit the reverse button. Hit the forward button. Nothing much happens. Okay, so
That's bad.
no, that's right.
Oh, okay.
If you look at the wiring, that light would come on, but the controller won't change directions.
Okay.
Okay, the next thing we're going to do is we're going to look for running current.
Aha. You would have never found that.
Yep. So this is a clamp-on amp meter, and what we're going to do is we're going to use it to read the amperage flowing in the motor. So we're going to turn on the forward guy and clamp it around one of those wires. And what do you read?
1 amp.
1 amp. Okay, clamp it on two of those wires. What do you read?
1.1 amps.
1.1 amp. Okay, when you clamp it on all three wires, what are you going to read? Don't
1
clamp.
amp.
Don't tell me. 1 amp was the answer. The question is, what do you read?
0.
0. Why do you read 0 when you clamped onto all three wires, but you read 1 amp on just one and 1.1 on two? Now wait a minute, we have to get your face in here so we can get the expression on your face on the video.
I'm baffled. You got me.
Okay, well, this is three-phase power. Each phase is 120 degrees out of phase. So when I add them all together, I get 0. There's as much above the 0 line as there is below the 0 line on my sine wave of a 60 hertz signal. So when I only have one wire, I see the current in that one wire. Each wire independently would be 1 amp. But because it's a sine wave function, half the time it's above 0, half the time it's below 0. When I clamp onto all three wires, they cancel out.
Gotcha.
Okay, next thing we're going to look at is we're going to look at starting current. What we're going to do is put the clamp-on amp meter onto one wire, and then we're going to go and start it and see how high we go. And what'd you say?
1.
No more than 1?
Yeah.
What'd you say?
4.6.
4.6. That's much better. 4.6. Now, the motor is a generator as well. So if I can turn this off and turn it on the other direction, I can get it spiked a little higher. How high did it go that time?
It didn't change. It went 1.1.
1.1. So I'm not doing this very quickly. Okay. But we do have certain starting currents when the motors start up. And if they had a load on them, the starting current would be higher. Okay, we are done with the video of Lab 6. If I can figure out.